Hi guys, we're going to be looking at this picking the correct inference procedure worksheet today. And as you're watching the video, it's going to pause and ask you to fill in your answers. So even though like in the directions, it's going to go first to find the parameters and then state the hypotheses and then name the test. I'm going to have you read through it and we're going to look for clues and then you're going to pick which procedure it is first. So first we want to read, a store manager wishes to determine whether there is significant difference between two trucking firms with regard to the handling of egg cartons. In a simple random sample of 200 cartons on one firm's truck, there was an average of 0.7 broken eggs per carton with a standard deviation of 0.31, while a sample of 300 cartons from a second firm showed an average, weird typos, of 0.775 broken eggs per carton with a standard deviation of 0.42. Is there a difference between the averages at the 5% level and then at the 1% level? So first, we're just going to have you pause and see, based on some keywords like average and a difference of averages and the information that they gave us, okay, based on that, can you pick which kind of test this is? All right, so it does help to know first off what type of information you're given. You're given two different samples, so I would use a subscript of 1 and 2. You have a simple random sample of 200 cartons from truck firm 1, so I'm going to do some subscripts of 1. They give you that in the first one, it has an average of 0.7 broken eggs per carton and a standard deviation of 0.31. Then they give you some second sample data. And I'm just writing it the way that it might show up with the notations, because if you have the wrong notation for some of this stuff, you'll get dinged. And I guess I should have done S sub 1 and S sub 2 for this one. And the units on these also are like the number of broken eggs per carton. All right, so hopefully you noticed you have two samples and you're talking about means. So the first part of this whole journey is defining our parameters. So the two things that we're looking for are the average number of broken eggs per carton. So for mu sub 1, that's our first parameter. We're going to define that as the average, or you could say the mean number of broken eggs from trucking firm number 1. And then mu sub 2 is going to be the average number of broken eggs I guess I should say per carton. Okay, so that's part A. So part A is just asking you to identify the correct parameters and define them. Part B, we're going to need to set up the pair of hypotheses. So this is where we're saying, is there a difference? Okay, they don't indicate a direction if one is better than the other. So I'm going to pause and let you answer, which one is our pair of hypotheses. Okay. So part B, we should say our null hypothesis would be that they're the same. There is no difference. And your alternative hypothesis to that would be that there is some sort of difference in how many eggs get broken for each group. So that's part B. And then part C, I know you already did, but here comes the answer. This is called a two-sample t-test for means. And then you'd go through and, finish the problem. And technically, we're kind of skipping around. Before you go through and do this actual test, remember there's that whole check for assumptions before you do stuff. Okay, so it's a two-sample test for means. When you're defining that stuff, also give information like alpha was 5%. Do that, and then they also had another and also at 1%. So sometimes that p-value will be rejected at the 5% level, but not at the 1% level. Like if your p-value is 0.04, you would reject at the 5% level, but you wouldn't at the 1% level. So little trick type stuff for that. Okay. All right, let's look at number 2. A company claims that the mean weight per apple that they ship, more shipping of produce, coronavirus, they have an average of 120. Oh, sorry, they claim. Ooh. So they're making a claim about mu. And they also say that they have a standard deviation of 12 grams. Then you actually take a sample of 49 and it has a sample of 122.5. So they're actually giving you a little bit more, it looks like. But it just says, do you have evidence to reject their claim? So based on this given information, can you pick which type? All right. So first step, define our parameter. This guy is definitely going to be a mu. So let mu equal the mean weight per apple shipped by the company. All right. Next thing that you're going to do is write your pair of hypotheses. This is a test, right? You're going to, is there sufficient evidence? You have to do test, not an interval. So for our test, we need a hoe. They said that it is 120 grams. We need to put the units per apple. And your ha, is that we're just saying are we rejecting their claim or not? So this would be a not equal to. All right. Now we're going to go back and name the test. This one's a little bit tricky. Technically, since you had sigma, there was a known sigma, you could use a z-test for means, but that's uber rare, right? So a better option would be just having a one sample t-test for means. And if you're looking on your calculator, it would just do a t-test. So lots of different options there. They didn't state which significance level to use, so I would say, at alpha of 5%, because that's traditional. Number 3, data taken from a random sample of 60 students chosen from a student population from a large urban high school area that's like inner city indicated that 36 of them plan to pursue post-secondary education. An independent random sample. We have independent random samples, awesome, of 50 students taken from a neighboring large suburban high school resulted in data indicated that 31 of those students plan to pursue post-secondary education. Do these data provide sufficient evidence to reject the hypothesis that these proportions are equal? So I butchered that, but we have some clues. We have sample and numbers. We have this word here. That should be a huge clue. Okay. So name the procedure. All right. Hopefully you said proportions. So the parameter that we're going to look at should be P. And you have 2 different proportions or 2 different samples going on here. So you can use 1s and 2s. I get confused when I do that. So I'm going to use like urban and suburban. So P suburban is going to be, for me, the proportion of students from a large urban high school that plan to pursue post-secondary education. How many of them plan to go to college or some sort of career training, tech training after? And then we can kind of cheat for suburban. Okay. Suburbia. We had a bunch of information given to us in that. So like we had N sub 1, we had 60. Out of those, how many of them said that they would? So we technically have a P hat, kind of given to us. We also were told the second sample size and how many of, not X bar, ooh, bad, not means, totals. Total number of kids there that said that they were going to go on to college. And then we have that P hat 2 calculation. So I'm writing that. You don't have to do that here, but just so you know, if we needed to go and check assumptions, all of that's critical information for me to make those decisions. And then also be able to calculate, do we have enough independence and all that stuff. Here we need to go through. So we just did, defining the parameter. That's part A. Oops. Part B is to write your pair of hypotheses. So I'm going to give you some choices here. All right, hopefully you picked correctly. If we're going to go through and say our ho and our ha, your ho should be that there is no difference. Your ha is that there is a difference. Okay, they didn't indicate that, the kids in the inner city are not going to go to school as much as the kids who live in like the nice suburban neighborhood. So the type of test that we would then go through to perform should be a 2-prop Z test. Again, alpha wasn't stated, so I would use 5% alpha. You can also say that this is a Z test for proportions, but you need to mention that it's like a 2-sample Z test for proportions. I would never write it out that much. I would go with the 2-prop Z test. Okay. Next one. This table shows the sample results of a hypothetical poll given to members of 3 different political parties, Republicans, Democrats, and Independents. Each person was asked the question, should more money be directed to schools to hire more teachers? And so we have a two-way table. Do these data provide or support the claim that a person's opinion in this issue is related to their political party? So this is the chapter that we kind of got cut off on, and this is hopefully at least obvious that you should do some sort of chi-squared test. The difference now is between, like, can you narrow it down from there? So things that you want to take into consideration before you make this choice is they found 3 separate political parties. So you have 3 different populations. I don't know what just happened in my little thing, but I'm still writing. All right, 3 different political parties or 3 different populations, and they were all asked one question. The same question was asked of all of them. So they really only collected this one variable. So if you have multiple populations, but you're only collecting one variable from them, is that what type of test? Okay. So now we have to go through, and I wouldn't define any variables here. Like, you don't define the population parameter for chi-squared tests. You are dealing with proportions, but that's not necessary. So understanding that this was a chi-squared homogeneity of proportions test, you, like I said, had different proportions for the different populations. Like, you had 3 different populations, and you're trying to see, are those breakdowns or are those proportions the same for each group? So our hoe in this case should be that there is no difference, right? There is no difference in the proportion of, like, agree or disagree opinions on this issue for the different political parties. Okay. The proportions of Democrats who agree is not different from the proportion of independents that would agree, and so forth. Our ha would be that there is a difference. All right. Number 5. This before and after should be a huge clue. All right. So if we have before and after, and they're talking about an average or a mean, then we want to go through and say, like, what is the difference? Okay, so, all right. So on this problem, because you're looking at, did they change by at least 50 points, and you have 8 members, and those 8 members, like, that's one person's score, like, that's important. Those are tied together. These samples are not independent. Like, the before group is the same group as the after group, and that one person's score matters. So you wouldn't actually use this data as it is. You'd have to go through and look at mu sub d. So we do want to look at the mean difference. That's the thing that we're comparing. So was there an increase? We want to know that we would be looking at or subtracting the after and minus the before. Okay, so somehow define what that average difference is. So this would be the mean difference in the student score on, what is it, SAT math. With the SAT prep. It's like, did the company make a difference? And they're making a claim not that it just like is different. They're saying that they get at least 50 points higher. So our hoe on this one would be that it's like 50 or less than 50. So the average difference is 50 versus our ha would be that it's at least 50, means that I would get more than 50 points of an increase or an improvement, right? We're improving by at least 50 points means I want to be able to say, did I get higher points using this company? So this type of test, when we go through to check the assumptions, we're checking the assumptions for a matched pairs t-test. Okay. And they did say alpha was 5%, so I would include that. So match pairs t-test is that type of problem. Number 6, when 10 cars of a new model were tested for gas mileage, the results showed a mean of 72.2 miles per gallon and a standard deviation of 1.8 miles per gallon. What is a 95% confidence interval estimate for the gas mileage achieved by this model? So defining our parameter, let's see if you can figure out what that is. So they did say mean. I would define this as mu equals the average, or I could say the mean gas mileage for new models of this car. Okay, we don't mention the sample size here because we want to know like the population, right? So they do say n is 10, they give you x bar, and they give you s sub x. They talk about then an interval. So should we define a ho and a ha for a confidence interval? Absolutely not. So you can use a test, or you can use an interval to test claims. That's fine. But if they don't ask you to test a claim, you're not testing a claim. So no hypotheses need to be stated here. So we just want to know the test name. And this should be a one sample t-test for means. Oh, I just said it's not a test. T-interval. Okay, so in our calculator, it's just a t-int, and confidence level should be 95. All right, number 7, North Carolina, maybe North Carolina, I don't know. North Carolina State looked at the factors that affect the success of a student in a required chemical engineering course. Students must get a C or better in the course in order to continue as chemical engineering majors. There were 65 students from urban or suburban backgrounds, and 52 of these students succeeded. Another 55 students were from rural or small town backgrounds, and 30 of those students succeeded in the course. Is there good evidence that the proportion of students who succeed is different for urban, suburban versus rural, small town backgrounds? Okay, so identify the test. So they did talk about proportions. We have totals and how many of each sample succeeded. How would we define these parameters? I'm just going to call this 1. So here's group 1. Ooh. All right, so hopefully pick the right one there. Our ho and our ha. Go ahead and pick. Are they different? Just be a not equal to for our alternative. And then if we name our test, this should be a 2 prop Z test. Okay, last one. A bank wonders whether omitting the annual credit card fee for customers who charge at least $2,400 in a year would increase the amount charged on its credit cards. The bank makes this offer to an SRS, or simple random sample, of 200 of its credit card customers. It then compares how much these customers charged this year with the amount that they charged last year. The mean increase is $332 and the standard deviation is 108. Is there significant evidence at the 1% level that the mean amount charged increases under the no fee amount? Okay. So here, like this information is talking about who they're looking at. So like this is part of that population. The $2,400 is like a requirement for them to be a part of the sample. So they're only looking at customers who charge that much money in a year. Okay. And then they go through and they make an offer to a group of them. And they want to see like how much did it change? Like what was the mean increase? And this one, I don't know if I even want to touch on it. It does talk about the mean increase, the mean amount that it changed from year to year. And so this one's a little bit harder to see. Like what was the mean difference? Did it increase? So they are looking at the average amount of increase or difference in this problem. So based on how I defined my ho and my ha, like maybe you can pick the test after that. So we're looking at the mean or average increase in spending, or charged, I guess, on credit cards for customers. Oops. At least, darn it. Okay, the mean increase charged on credit cards for customers who charge at least that much per year when offered the no fee dealer. Okay. So based on that, can we pick the test? All right. Go ahead, and this program automatically gives you a grade and tells you what you got right and wrong. But still mark as done or submit it, or however it is that you turn stuff in on Google, so that we know that you finished. All right. Thank you guys.